Hello, you're welcome to our mathematics class. In mathematics, today we shall be looking at the topic sets. Set is a collection of well-defined objects. And in sets, there are several terms that we need to get accustomed to before we start solving questions. Let's take a look at the terms. For instance, you have P equal to A, B, C, D. What does this mean? It means that the elements of set P are A, B, C, and D alone. If you have this or this means a universal set. We are referring to all elements that could be mentioned under that particular subject. We have this sign, which means belongs to, or it also means a member of a particular set. And we could have this sign with a cross. It means is not a member or is not an element of a particular set, or it means does not belong to. Then we have this, or we represent it with this. This means a null set. Null set is an empty set that does not contain any elements. We have this sign which stands for union. That is, you merge the elements of two sets. We have this sign which stands for intersection. Intersection means what is shared between two sets, or what is common between two sets. We have NS, where N means number of elements in S. We have complement. Here is the complement. Complement means elements that are not parts of a particular set. So for instance, if you have A complement means elements that does not belong to A. Next, we have this sign, which means such that. Next, we have Z, which means integer. Next, we have N, which stands for natural numbers. And next, we have Q, which stands for rational numbers. And then we have disjoint sets. A disjoint set is a set that has nothing in common. And we have a Venn diagram. So meet all these terms in this particular topic called sets. And so we'll proceed into solving questions. Here's the first question. If P is a set of 1, 3, 5, 7, 9 and Q is a set of 1, 4, 9, 16, list the elements of the sets A, P union Q, and B, P intersection Q. So we'll solve the first part, which says P union Q. P union Q means we have to list the elements that can be found in P and Q without repetition. Now we have one in P and we have one here, so we have just one, and then we have 3, 4, 5, 7, 9, and 16. So this is P union Q. B part says P intersection Q. What does intersection mean? It means what do they have in common? When we take a good look at this, 1 and 1 can be found here, so they have 1 in common. What else do they have in common? We have 9 here and we have 9 here, so 9 is also in common. Here, this is what P intersection Q stands for. Here's the next question, which says find number of elements in the universal set. B, find number of elements in A. C, list the elements of A union B. And D, list the elements of A intersection B. Here we have a Venn diagram showing set A and set B. Now, the first question says that we should find number of elements in the universal set. The universal set is elements that we have here without repetition. So all the elements we have here, we have 1, 2, 3, 4, 5, 6, 7. And so from here, we have 7 elements. Number of elements in A. Here is A. A cuts across like this. Even though there is S and T being shared with B, but it also belongs to A. So all the elements in A are 1, 2, 3, 4. So we have 4 elements. Number 3, we have to list the elements in A union B. A union B. This time I want to list A union B means that all what we have in A and B together. We have Q, R, S, T, and U. These are the elements in A union B without a repetition. And lastly, we have to find all the elements in A intersection B. A intersection B is this middle. That is what we have that is common between A and B. Before we go about that, we have the elements in A to be Q, R, S, T. Q, R, S, T. That is for A. And then in B, we have S, T, U. In B, we have S, T, U. Now from here, we have that S and S are common, and then T and T are common in A and B. Those are the intersection. So we have S and T as the elements common between the two sets. Here's the next question. If elements of the universal set equal to 2, 3, 4, 5, 6, 7, and P equal to 2, 4, 6, and Q equal to 2, 3, 5, 7, find A, P complement, B, Q complement, C, P intersection Q, all into brackets, complement, D, P union Q, all in brackets, complement. Now, let's work the first one, P complement. What does P complement mean? It means that elements that are in the universal set but not in P. Now, in P, we have 2, 4, 6. What are the elements that we can find here but are not here? That is P complement. And so, we have 2 here, but we do not have 3, so we list 3. We have 4 here. We have 5 here, but 5 is not here, so we list 5. We have 6 here. We have 6 here. We have 7 here, but it's not here, so we list 7. So these are the elements of P complement. B, Q complement. So we are looking for elements that are here but not present in Q. We have 2 present here. We have 3 present here. We have 4 here, but it is not here, so we have 4 as a complement. We have 5 here. We do not have 6 here, so we list 6 here, and then 7 is also present in both. Next, we have to find P intersection Q. P intersection Q or complement. First, let's determine P intersection Q. That is, what is shared between P and Q. We have 2 between here. We have 2 present in P and in Q, so we list 2. What else do we have common? Nothing else. All right. Then we'll go about finding the complement. The complement will be what we have in the universal set but not in P intersection Q. We have 2, but every other one are not present, so we'll list 3, 4, 5, 6, and 7. And D, we have to find P union Q or complement. First, we'll find P union Q. P union Q are the elements that are found in the 2 of them without a repetition. Here we have 2 present in the 2, so we take 1, and then we have 3, we have 4, 5, 6, and 7. Now, P union Q complement means what we have here but not present here. When we take a good look at it, we'll find out that everything that we have here is also present here. And so we have an empty set or a null set. Here's the question that says, draw a Venn diagram with sets universal A and B such that number of elements in A intersection B equal to 5, number of elements in A union B or in complement equal to 8, and into brackets A complement intersection B equal to 2. If number of elements in the universal set is 26, find number of elements in A intersection B complement, then close the brackets. B, N open bracket A complement union B complement, then close the brackets. We have a universal set. So we'll represent that with this. So we have a universal set like this, and it contains two sets. We have A and B, and such that number of elements in A intersection B equal to 5. So we can get that done by saying that if there are 5, let's say we have 1, 2, 3, 4, 5. These are the 5 elements there. And then we also told that number of elements in A union B complement. A union B means all of A and all of B. Then the complement means what is not inside here at all. That means will be outside. Now without information, we have to put 8 numbers outside. So let's say that the numbers we'll put will be 19, 20, 21, 22, 23, 24, 25, and 26. And next we were told that number of elements in A complement intersection B equal to 2. What does that mean? A complement means what is not in A at all, right? A complement. And what is not in A at all will be what is in B over here and here, then intersection B. That means that it is only in B. Now with that information, we are told that we need just 2 numbers there. Alright, so let's have 6 and 7 there. And then we are now told that if number of elements in the universal set is 26, meaning that if we count all the elements inside this universal set, it should be 26. But here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we need to complete 26. So we have 7 here. We could have 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. So with this, we now have 26 elements. Now the first part of the question says we should find the number of elements in A intersection B complement. What does this mean? We have A, the elements in A are all this. Intersection B complement. What is B complement? This is B. Then the complement of B. So let's state it that B complement equal to what is not in B at all. So what we do not have in B at all are all this. So we can list them. We have 8, 9, 10, 11, 12, 13, up to 26. And then what are the elements in A? In A, we have all this in A. So we have 1, 2, 3, 4, 5, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. These are all the elements in A. Now what are their intersection? That is, what are they sharing in common? What they are sharing in common starts from 8. That is, we can find 8 in both of them. We can find 9 in both of them. So we have to look for what they share in common. Now from here, we have 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. It's also here. So how many do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And so we have that number of elements in A intersection B complement equal to 11. The B part says number of elements in A complement union B complement. Now what we need to do is first to find A complement. A complement means, now this is A. Everything in A is here. But A complement are the things that are not inside A. That is what we have outside here, 6, 7, and 25. So we'll list the A complements. The A complements are 6, 7, 19, 20, 21, 22, 23, 24, 25, and 26. Next, B complement. Here is our B. but the B complement are the elements that are not found inside this circle. And so it's going to comprise of what we have here and this. So let's list the elements in B complement. We have 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, then 19 to 26. We have to find the union. The union means that we should combine them all together. To combine them all together, we can start from 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. And so if you count all what we have here, we have 1, 2, 3, 4. So we have that A complement union B complement will be from 6 to 26. And so the number of elements there equal to 21. So that is the answer. Next question says, given universal sets equal to x such that x are all positive integers from 1 to 20, p are a set of numbers such that x are factors of 18, and r equal to x such that x are all even numbers, then r intersection p is what? Now in this question, we have to find r intersection p. First, we need to identify all the elements in the universal set. We are told that they are all positive integers, where n means integer. And so we have the integers from 1 to 20. That's 1, 2, 3, 4, up to 20. Then for p, we are told that they are factors of 18. When we are talking about factors of 18, those are numbers that when we multiply them, they are capable of giving 18. And so when we have, for instance, 1 multiplied by 18, 2 multiplied by 9, 3 multiplied by 6. Now, the factors of 18 that we are talking about here will be 1, 2, 3, 6, 9, and 18. So we have 1, 2, 3, 6, 9, and 18. And next, R. X such that X are all even numbers. The even numbers that we are talking about here will fall within 1 to 20. So we have 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. These are the even numbers. Next, we have to find R intersection P. R intersection P means that what do they share in common? So what do we have in common between R and P? Here, 1 is here, but 1 is not here, so that's out. But first, we have 2 is common here, we have 4 here, then we have 6 common, 8 is not common, 10 is not common, 12 is not common, 14 is not common, 16 is not common, 18 is common. And so, R intersection P are 2, 6, and 18. In this next question, we're told that in a small village of 500 people, 350 speak the local language, while 200 speak Pidgin English. What percentage of the population speak both? Here, we can represent this in a Venn diagram, where here we have our universal. The universal, we're told that we have 500 people. And in this village, we have 350 people who speak local language and 200 which speak Pidgin. Out of these 350, we have some that can speak both. Likewise, from the 200 that speak Pidgin, we have some that can also speak the local language. So we have 200 minus x here, and we have 350 minus x here. And so what percentage of the population speak both? Now for us to get those that speak both, which is x, we need to determine the x like this. We have that 350 minus x, that is only those that can speak only the local dialect, plus those that can speak both. plus those that can speak only pidgin, which is 200 minus x, will give us the total number of people in the village. What we'll do first is to collect like terms. Minus x plus x cancels out. So we have 350 plus 200 minus x equal to 500. 350 plus 200, that gives 550 minus x equal to 500. When we bring this minus x here, we have plus x, and then we have 550 minus 500. And so the value of x equal to 50. So 50 people are those that can speak both the local language and pidgin English. Now, the percentage of those that speak both. So the percentage will be 50 over the total number of people in the village, which is 500 multiplied by 100 over 1. And so all this goes, 5 gives 10. And so we have 10% as the answer. Next question says, if x equal to n squared plus 1 such that n equal to 0, 2, 3 and y equal to n plus 1 such that n equal to 2, 3, 5. Find x intersection y. Now in this question, we need to find the exact values of our x. We were told that n squared, and so we will have it that the value of x will be, now when we say n squared, meaning that we will substitute n with 0 at each point. So n squared, that is 0 squared, which is 0 plus 1, that gives 1. Then we'll put 2 as well. 2 squared is 4, 4 plus 1 is 5. Then we'll bring 3 also in there. 3 squared is 9, 9 plus 1 is 10. And then we have y. For y is n plus 1. So if n is 2, so 2 plus 1 is 3. If n is 3, 3 plus 1 is 4. And if n is 5, 5 plus 1 is 6. And so we are to find x intersection y. Now n intersection y, okay, we have to find x intersection y. Now x intersection y are what is common between x and y. And when we look at it carefully, there is nothing common between x and y, and so we have an empty set. So that is the final answer. Here's the next question. It says, from the Venn diagram above, the shaded part represents what? Now when we look at this Venn diagram, we have P, Q, and R. Now when we look at P and Q, over here it is shaded, and so where that place which is shaded is known as P intersection Q, right? And then we have P and R over here, and if you look at it carefully, if you look at it closely, we have this place is also shaded, which is P and R. So this is P intersection R as well. Now when we take these two and we combine it together, it forms this. And so when you combine it together, combination of the two is a union. So when you have a union, this is what you finally have at the end of the day. Next question. In a survey of 50 newspaper readers, 40 read Champion and 30 read Guardian. How many read both papers? Here we have a universal set of 50 newspaper readers. We have two newspapers, Champion and Guardian. We're told that 40 read Champion. Now if we put 40 here, 40 will be for the entire circle. But out of these 40, we have some that also read Guardian. So they are not only reading Champion. And then we have 30 that read Guardian. So we have 30. And out of these 30, We have some of them that read only Guardian, and we have some that read both Guardian and Champion. So we have X. And so we have to subtract X from both sides. We have to find those that read both newspapers. So what we'll do is we'll add each of the segments. Now for those that read only Champion, that will be 40 minus X, plus those that read both, which is X, plus those that read only Guardian, that is 30 minus X, equal to 50, which is the total number of newspaper readers. So to find the value of X, we have minus X plus X cancels out, so we have 40 plus 30, which is 70, minus X equal to 50. So we bring this minus X over here, becomes X equal to 70 minus 50. So X equal to 20. So those that read both newspapers are 20 people. Question. In a school, 220 students offer biology or mathematics or both. 125 offer biology and 110 mathematics. How many offer biology but not mathematics? So in this question, we have a school that offer mathematics or biology or both. In this school, we're told that 125 offer biology. So we have biology and mathematics. Now 125 offer biology, but not only biology. So out of this 125, we have some that offer both biology and mathematics, which is X. So we have minus X here. And then we have 110 that offer mathematics. So we have 110 minus X. We have to find the number of students that offer biology but not mathematics. So what we need here is those that offer only biology. And to get those that offer only biology, we need to first get the value of X, and then we'll subtract it from 125. And so here is how it is done. So we have 125 minus X, which is those that offer only biology, plus X, which is those that offer both, plus 110 minus X, which is those that offer only mathematics, equal to the total number of students. We collect like terms. Minus X cancels plus X. We have 125 plus 110. That gives 235 minus X equal to 220. We collect like terms. That is, we bring minus X over here, becomes X equal to 235 minus 220. And so we have 15. Hence, 15 people offer both subjects. With this, we can get those that offer only biology. That is what biology but not mathematics means. So we have 125 minus 15, and that gives 110. And so those that offer biology but not mathematics are 110. Next question. In a class of 40 students, each student offers at least one of physics and chemistry. If the number of students that offer physics is 3 times the number that offer both subjects, and the number that offer chemistry is twice the number that offer physics, find the number of students that offer physics alone. For this question, we can have a Venn diagram of such. We have, in a class, we have 40 students, and we have those that offer physics and those that offer chemistry. From the information provided, we're told that if the number of students that offer physics is 3 times those that offer both, and so let's say those that offer both is X. So we are saying that those that offer physics equal to 3 times X. And then we're also told that the number that offer chemistry is twice the number that offer physics. So we have that chemistry equals to 2 times those that offer physics, according to the information there. We have to find the number of students that offer physics alone. For us to solve this question, when we look at this and this, we have something common, and that is P. So what we could do is to link each of the spaces inside here, that is each of the segments or the sector, by having a P. And with that, we can easily find P, since P is now the only variable that we do not know. And so what we'll do is this. We'll say that for this one, let x be equal to P over 3. Here we've made x the subject of this formula. And so in this place, we have P. And in place of this x, we'll put P over 3. And then in place of C, we'll put 2P. That is those for chemistry. Now, we need to also take note that the P that we have here is for all of those that offer physics. Meaning there are some that offer only physics, which we have not captured. And then this 2P is for those that offer chemistry. And so we need to know those that offer only chemistry. And that can be done by saying that P minus P over 3. Since P over 3 is for both, those that offer both, so P minus P over 3 will give us for only physics. And then over here, to get for only chemistry, that will be 2P minus P over 3. We'll add all this and we'll equate it to 40. So we have P minus P over 3 plus P over 3 plus 2P minus P over 3 equal to 40. Minus P over 3 plus P over 3 cancels out. And so we have P plus 2P. That gives 3P minus P over 3, which is equal to 40. We can find the LCM of this, and we have 3. 1 in 3, that's 3. 3 times 3P, that gives 9P. 3 in 3, that's 1. And then we have P equal to 40. 9P minus P, that gives 8P equal to 40 multiplied by 3, that's 120. And so we have P equal to 120 divided by 8. When we divide this, we'll have 15. Now, so this P got in is for those that offer physics, but not physics only. Now, to get those that offer physics only, we need to get this P minus 3, and we'll subtract it from 15. And so to get P minus 3, P is 15 over 3, and that is 5. So this is those that offer both. And so to get physics only, that will be 15 minus 5, and that is 10 students. Next question. The Venn diagram shows a class of 40 students with the games they play. How many students play 2 games only? Now, here is the Venn diagram. For football, we have 2, 5, 4, 7. Now, what does this mean? It means that we have 2 students that play only football here. 9 here means we have 9 students that play only tennis. We have 5 that play only athletics. While this 4 is for those that play only football and athletics. So for football and athletics, only 7. So we have 7 students for the 2. Those that play only tennis and athletics, that is 3. And then those that play only football and tennis, that gives 5. So we have football and tennis, which is 5. So these are the combination that play only 2. And for those that play the 3 games, that's 4 students. But this is what we are required to find. So we just need to add this. So 7 plus 3, that's 10. 10 plus 5, 15. And so 15 students play only 2 games. Next question says, set of P equal to 1, 2, U, V, W, X. And set of Q equal to 2, 3, U, V, W, 5, 6, Y. And set of R equal to 2, 3, 4, V, X, Y. Determine P minus Q intersection R. Now we are bringing in a different sign here, which is a minus. Now what does this minus mean? Minus mean that there is something that this has over this, and so whatever this has over this will be brought out. And so we'll compare P and Q and we'll look for what P has but Q does not have. So I'll look at it carefully. 1, P has 1 but Q does not have 1, and so we have that P minus Q contain 1. There's 2 here, 2 is here, U is here, U is here, V is here, W is here, X. We have X here and X not here, so we have X as well. So that is P minus Q. And then intersection R. Intersection R means what do R and this share in common? And so when we look at this carefully, what do they share in common? So P minus Q intersection R. We have 1 here, but 1 is not here. The only thing they share in common is X. And so the answer to this question is X. Next question says, a bookseller sells mathematics and English books. If 30 customers buy mathematics books, 20 customers buy English books, and 10 customers buy the 2 books, how many customers has he altogether? In this question, we can represent it with a Venn diagram where we have mathematics and English books. We have a universal set which is unknown. We're told that 30 customers buy mathematics books, but not just only mathematics. And then 20 customers buy English, but this 20 is not for only English. And then 10 buy both, so we have 10. So to get those that buy only mathematics, so to get those that bought only mathematics, that will be 30 minus 10. And for those that bought only English, that will be 20 minus 10. And so we have 30 minus 10, that gives 20, plus 10, plus 20 minus 10, plus 10. And so the total number of customers altogether will be 40. Next question says, if P equal to set of P, X such that X is odd, minus 1 is less than X, and X is less than equal to 20, and Q equal to Y such that Y is prime, minus 2 is less than Y, and Y is less than equal to 25. Find P intersection Q. Now in this question, we need to state our sets or our elements of P and the elements of Q clearly. First, we're told that X is odd number here. So here we have minus 1 is less than X, and X is less than equal to 20. What does this mean? If we say minus 1 is less than X, meaning that X is greater than minus 1. And so what are the numbers that are greater than minus 1? That goes from 0, 1, 2, 3, and then then we have X is less than equal to 20 until we get to 19 and 20. And so all this agree with this inequality that we have here. We are told that elements of X are odd numbers. And what are the odd numbers here? We have 1, 3, 5, 7, 9, 11, 13, 15, 17, and 19. So all these are the elements of P. Next, we move on to Q. For Q, we have minus 2 is less than Y, and Y is less than equal to 25. With this information, if minus 2 is less than Y, it means that Y is greater than minus 2. What are the numbers that are greater than minus 2? It starts from minus 1, 0, 1, 2, 3. And then we're told that Y is less than equal to 25. So Y is less than equal to 25. That means we'll continue counting until we get to 24 and 25. So this is what satisfies these inequalities. But we're told that the elements of Y are prime numbers. And prime numbers are numbers that can only be divided by themselves and 1. And so the prime numbers that we have here include, now we'll take 1 out as not being a prime number. And so we have 2, 3, 5, 7, 11, 13, 17, 19, and 23 as the prime numbers. And so these are the elements of Q. And so to now find the value of P intersection Q, that is what they are sharing in common. What do they have in common? 1 is here, but 1 is not here. We have 3 here, so we list 3, 5, 7, 11, 13, 17, and 19. And so these are the elements in P intersection Q. Next question says the shaded region in the Venn diagram below is what? Here is a Venn diagram. We have P, Q, R, and then over here, this place is shaded. We'll explain this plainly like this, and then we'll explain using this Venn diagram over here. In the first instance, when we look at this Venn diagram, we'll notice that all around P, there is nothing shaded there, right? So if nothing is shaded in P, it means that that is P complement. P complement means that nothing over here is shaded. And then we will consider this Q and R. Just a small portion here is shaded. But what if the entire part is shaded? That is, if everything here is shaded, that would have been Q intersection R, right? So if everything here is shaded. But from what we see here, this part has been removed from the entire intersection. And what does that mean? It means that there's an intersection of this with the unshaded region, that is P. And so this is what this Venn diagram stands for. And then we could use this. From here, what we need, the shaded region is only 6 according to this Venn diagram. If you look at this diagram carefully, if you are asked that what is P complement, P complements will be 3, 6, 7, while P itself is 1, 2, 3, and 5. We have 6 here. 6 is being shared between Q and R. And so we could say that that is Q intersection R. Q intersection R means what is shared between Q and R. From here, Q and R are sharing 6 and 4. Now we need only 6 to remain, since that is the shaded region. And for us to get that as the shaded region, we only have P complements to be 3, 6, 7. So to get 6 out is to get an intersection. And so P complement intersection Q intersection R will be 6, since 6 is what is common between P complement intersection Q intersection R. Next question says, in a survey of students, it was discovered that 76 like history, 98 like geography, and 87 like mathematics. 15 like all the 3 subjects, 39 like history and geography, 37 like history and mathematics, 48 like geography and mathematics, and 45 like none of the subjects. A. Show this information using a Venn diagram. B. How many students took part in the survey? Alright, so in this question, we are expected to show the information read on a Venn diagram. But let's take note that the information we are given, we cannot directly enter them into the Venn diagram, not until we have solved the puzzle. Here we have 3 subjects. History, the second is geography, and then we have mathematics. In this school, we have that 76 like history. And so the 76 that we have here is for history entirely. Now, not just history alone. And next we have that 98 like geography. So 98 given here is not only geography that they like, rather geography entirely, meaning there are some that will like history and geography, some will like mathematics and geography, and some will like geography, history, and mathematics. And then 87 like mathematics, so we have 87 over here. We're further told that 15 like all the three subjects, so we have 15 in this small place. Then 39 like history and geography. For history and geography, we're told that 39 like history and geography. But let's take note that history and geography, the 39 we're given here is not entirely for history and geography. And then we're told that 37 like history and mathematics. So we have 37 over here. And lastly, okay, and we have that 48 like geography and mathematics. And so we have 48. And lastly, we have that 45 like none of the subjects. And for those that like none, it comes outside the tricycles. We do not know the total number of students we are dealing with. For us to get the actual number of students that like only history, or to get the actual number of students that like only geography, or those that like only mathematics, or those that like only history and mathematics, or those that like only geography and mathematics, or those that like only history and geography, we need to sort this out. And this is how we get it done. The first thing we need to do is, this 15 is for those that like the three subjects. To get those that actually like history and geography. Now, this 39 we have here is not only for history and geography. Rather, there are some coming from mathematics, which are included here. And so to get that, we'll have it as 39 minus 15. 39 minus 15, that gives 24 students. And so those that love history and geography only are 24 students. To know those that love history and mathematics, the 37 given here is for those that love history and mathematics, out of which there may be some that also love geography. And so to get this only, okay, so we need to place only over here. So to get those that love history and mathematics only, we'll have 37 minus 15, and that leaves us with 22 students. Those that love geography and mathematics only, we have 48 for those that love mathematics and geography, meaning there's a mixture of some history in here. And so we'll have 48 minus 15, and that leaves us with 33 students. Next, we need to get those that love history only. How do we get those that love history only? From this 76 here, we have a combination of this inside this circle, we have this inside this circle, and we have this inside this circle. And so what we need to do is to take all of this out from this 76. And here is how it's done. We have 76 minus 15 minus, we will not take this 37. Rather, we will take those that only love history and mathematics only. And for those that love history and mathematics only, we have 22 of them. And then this part for those that love history and geography only. And from here, history and geography only, we have 24, so minus 24. So with this, we have 76 minus 15 plus 22 plus 24. When we total this, we have 15 students. Next, let's derive those that love geography only. For geography only, here, this is the entire student that love geography. That is 98. 98 love geography entirely. So we have 98 minus what we have in here, that is history and geography only. History and geography only, which is 24. Then minus those that love the 3 subjects, which is 15. Minus those that love mathematics and geography only. That is geography and mathematics only. That is 33. Minus 33. And so this means 98 minus 24 plus 15 plus 33. That leaves us with 26 students. We will determine those that love mathematics only. For mathematics, those that love mathematics as a subject, we have 87 of them. But those that love mathematics only will be mathematics minus those that love history and mathematics only, which is 22, minus those that love geography and mathematics only, geography and mathematics only, we have 33, minus those that love the 3 subjects, 15. And so when we find this out, we would have 17 students. Now from this information, we can find the total number of students that took part in this survey. And how is that done? The total students will be total number of students that love only history. For only history, we have 15. Total number of students that love geography only. Geography only, we have 26. Those that love mathematics only, and that is 17, plus those that love a combination of history and geography only. And so for history and geography only, we have 24, plus those that love geography and mathematics only. Geography and mathematics only, we have 33, plus those that love history and mathematics only. For history and mathematics only, we have 22, and those that love a combination of the 3 subjects, we have 15. And then we also have 45 outside here. These 45 are those that do not love any of the 3 subjects, that is history, geography, or mathematics, and that's we have 45. And so when we add all this, we would arrive at 197 students. And so from this survey, 197 students took part in it. To draw the actual Venn diagram, the actual Venn diagram will look somewhat like this. And so here is history, geography, and mathematics. We have 45 that do not like any of the 3 subjects. We have 15 students for history. For geography, we have 26. For mathematics, we have 17 students only. And then for history and geography, we have 24 students only. For geography and mathematics, we have 33 students only. For history and mathematics only, we have 22 students. And for those that love the 3 subjects, we have 15 students. This is a Venn diagram. This is a Venn diagram for the first part of the question. In a survey of 290 newspaper readers, 181 of them read the Daily Times, 142 read The Guardian, 117 read Punch, and each reads at least one of the 3 papers. If 75 read the Daily Times and The Guardian, 60 read the Daily Times and Punch, and 54 read The Guardian and Punch. A. Draw a Venn diagram to illustrate this information. B. How many readers read all 3 papers? Roman figure 2 of B. How many students read exactly 2 of the papers? Roman figure 3 of B. How many readers read exactly 1 of the papers? Roman figure 4. How many students read The Guardian alone? So for this question, here is a diagram, a Venn diagram. We have 3 newspapers which are represented: the Daily Times, the Daily Times newspaper, the Guardian, and the Punch newspaper. We're told that we have a universal set of 290 readers in all. We have 181 that read the Daily Times. We have 142 that read the Guardian newspaper. We have 117 that read the Punch newspaper, and we're told that each read at least 1 of the 3 newspapers, meaning that we do not have any outside this place. And we're also told that 75 read Daily Times and Guardian. So we have Daily Times and Guardian, we have 75 over here, and 60 read the Daily Times and Punch. So Daily Times and Punch, we have 60, and 54 read Guardian and Punch. Guardian and Punch, we have 54, but we're not provided any information as to those that read the 3 newspapers all together. Now, this information we've presented in this Venn diagram is not a purely accurate one, because all we've gotten here are the numbers of readers. For instance, this 142 is comprising all those that read only Guardian, those that read Guardian and Daily, those that read Guardian and Punch, those that read Guardian, Daily and Punch. That is what this 142 is about. But we need to have an accurate number of those that read only this, only D and G, only Punch and Guardian, only Daily Times and Punch, only Daily Times, and the 3 of them. And so here is how we go about it. First, this X is being shared among all of this. And so to get those that read only Guardian and Punch, that would give 54 minus X. To get those that read only Daily Times and Punch, we have 60 minus X. To get those that read only Daily Times and Guardian, we have 75 minus X, which is this. So don't forget, these are for only. So this is 75 minus X, 54 minus X, 60 minus X. Then, for those that read only the Daily Times, how is that gotten? Here is the Daily Times, which is 181. It's going to be 181 minus this, which is 75 minus X. So we can place it here as 75 minus X minus what we have here, which is X, minus 60 minus X. 60 minus X. That is for Daily Times only. Next, for those that read Punch only. For Punch only, here we'll have 117, which is for Punch, the whole of Punch, minus those that read Punch and Guardian, which is 54 minus X, minus X, minus 60 minus X, 60 minus X. And for those that read Guardian only, here is Guardian. Now, this 142 is for the entire Guardian. So to get for Guardian only, we have 142 minus 75 minus X, minus this X, minus 54 minus X. And that's how we get that. When we have gotten the value of this, we add it together, and that will give 290. And so first, let's bring the like terms together in daily times. Let's bring like terms together in punch and also in Guardian. So here's how we go about that. We have 181. Here is minus 75. Minus times minus gives a plus x, and then minus x, then minus 60. Minus times minus gives plus x. And so we have x cancels x. 181 minus 75 minus 60, that produces 46. And then we have plus x remaining. Then for punch only, let's bring like terms together. We have 117 minus 54, minus times minus gives plus x, and then minus x, minus 60, minus times minus gives plus x. Plus x minus x cancels out. 117 minus 54 minus 60, that produces 3. And we have x here, so plus x. Next, for Guardian only, let's bring the like terms together. We have 142 minus 75. Minus times minus gives plus x, minus x, minus 54. Minus times minus gives plus x. And so we have 1 plus x minus x gets cancelled out. 142 minus 75 minus 54. That yields 13. And then we have plus x left here. So the next thing we need to do is this. After we have all this, we will sum them together, equate them to 290. And so we have 54 minus x plus 60 minus x plus 75 minus x plus 46 plus x plus 3 plus x plus 13 plus x. Alright, so we brought this, 46 plus x, 3 plus x, and 13 plus x. When we've written all this, do not let us forget that we still have x at the middle. So we've captured this, we've captured Guardian and punch, we've captured daily times and punch, we've captured daily times and Guardian, we've captured daily times only, Guardian only, punch only, and then we need to capture the 3 combination. And so we'll have a third plus x. Now when we add all this together, it's expected that we'll have 290. And so what we'll do now is to bring like terms together. Here we have the numbers, that is 54 plus 60 plus 75 plus 46 plus 3 plus 13. And then we bring the variables, the variable x. We have minus x minus x minus x plus x plus x plus x plus x equal to 290. This gives 251. And then we have minus x minus x minus x. This is minus 3x. And then x, that's plus 4x equal to 290. Now from this information, we will have it that 251 minus 3x plus 4x, that is plus x equal to 290. And so we have it that x equal to 290 minus 251, and that will produce 39. So finally we have our answer that 39 readers read all 3 papers. That is Roman figure 1 of B. Roman figure 2 says how many read exactly 2 of the papers. Now those that read only 2 of the papers are what we have here: 2 papers here, 2 papers here, and 2 papers here. So what we need to do is to add them together. Here we have them. And so we have our Roman figure 1 done here. For Roman figure 2, all we need to do is to place 39 in each of these x, and then we'll get those that read exactly 2. And so for the first one, 54 minus x, which is 39, that gives 15. 60 minus 39, that gives 21. And then 75 minus 39, that gives 36. And so those that read exactly 2 of the papers, we have 15 plus 21 plus 36. These 3, when we add them together, we will have 72. And so we have that 72 readers read exactly 2 of the papers. Next, we are told to find those that read exactly 1 of the papers. Now, how many readers read only Guardian? We'll get that. How many read only Daily Times? We'll get that. How many read only Punch? We'll get that. And when we have gotten that, we'll add them together to give our Roman figure 3. And now, so here's how we get that done. Here we have 46 plus x, and our x here is 39. So 46 plus 39, that produces 85 readers. And then 3 plus 39, that produces 42 readers. 13 plus 39, that produces 52. So for those that read exactly 1 of the papers, we have 85 plus 42 plus 52. And when we add these 3 together, we end up having 179. And so 179 is the answer for this, for those that read exactly 1 of the papers. And the fourth says, how many readers read the Guardian only? And here is Guardian only, we have 52. So we have 52 readers for Guardian only. Here is the solution to this complex but simple Venn diagram problem.